Welcome back to part 4. We've got a new notebook file, so let's just call it part 4. Again, hopefully you're following along, and there will come a point where we are done in Jupyter notebooks, and we'll dive into just legitimate Python files that, again, read from top to bottom with the loops and everything else. And we're not quite to loops yet. You might be wondering, when are we getting to loops? But I really think it's important to get you really understanding what happens when you, inadvertently copy the list's name and you accidentally modify the list in two places. Just little things like that. That's what we're doing early on, is getting you really aware of what Python's going to do versus what you might think it will do when you write a line of code. That way it just is that much easier when we really start building some complex stuff. So we've got a little bit more to go before we really start building and seeing what Python can really do for us and speed up our work. Because right now we're typing everything to accomplish all of our tasks. When does this code start actually doing something for me faster than I can think it, or faster than any human could do on their own? Right now it just seems like I'm writing a bunch of stuff and manually doing it all myself. Trust me, we're getting there, but we're building that foundation. So one of the last things in that foundation before we start seeing the magic is logic and math, unfortunately. So let's dive in. So first, let's do the math part. I think for me that's easier just for my background. So with math, we know that, we can do addition. 4 plus 16. Let me get my Python environment set up. And, you can see it set up there. Hey, look, we get 20. So basic addition is in Python. You can also then do subtraction after. You don't need to do one bit of math at a time. You can do all three, and it will follow your typical order of operations. And you can also change the order of operations by putting in parentheses. So you can do kind of that old school high school math or even like middle school math, where you can make those kind of challenging problems, like the silly ones on Facebook you see all the time, where it's like, what is 5 plus 5 plus 5 times? Hey, that's how you do times. You press shift, 8, and maybe you want to times it by 10. Those silly questions where it's like, what will this be? And everyone disagrees. Well, according to Python, you get 105. So the parentheses can override the order of operations there. If we don't have the parentheses, let's see what we're going to get. Something totally different. I think 60. Yep. And you can investigate why. And again, it has to do with basic order of operations. Parentheses comes before multiplication. So if there are parentheses, then they will take precedence before the multiplication. So there you go. All right. Basic addition. Hey, there's multiplication. Well, we probably can guess that there is subtraction. So 60 minus 10 is 50. Now you can also see that we don't need the spaces in between. It's going to know you're trying to do a mathematical statement. Now what we can also do is division. And before we showed you that, hey, if you take two integer values and you divide them, you're going to get a float out of that. That was one of the first things we did. And by the way, you can do addition, subtraction, multiplication with floats as well, and then you will get a float in, let's just show you that once. If I put 5.0 even though that's still 5, the minute you inject a float into an expression, you're going to get a float out. So once a float makes its appearance, it's definitely going to be there, even if it doesn't have to be. With addition, subtraction, multiplication. And with division especially, you're going to get a float no matter what. With a caveat, we'll find some ways around that. So if you don't want a float, then you don't need a float. But if you need to put a float inside your mathematical computation, well, then you'll get a float out. Let's just deal with simple numbers. So division, right? We got a float out. And I've been hinting that there's ways around that. And one of the ways around that is we can use this double division symbol, which actually means kind of like, I'm going to say floor division. And what I mean by that is we get 5 out of this. And we know the true answer is 5.6 repeating, or 5 2/3, because 3 goes into 17 5 times with a remainder of 2. So 2/3, 0.6 repeating. And here we just got 5. So what's going on there? Well, this is what we mean by flooring. It means whatever comes after the decimal point, I don't care about it. Just chop it off, throw it away. I don't care if it's really, really, really close to 6. Like this could be 5.999999999. But hey, if I do double division, then that 9 repeating is just going to get chopped all the way down just to the last whole integer. And I think we even sometimes call this integer division. It just gives you how many times, that classic phrasing of how many times does 3 go into 17? Well, it can go in 5 times exactly, but there's a little bit left over. So you're getting the 5 without the leftover. And well, what if you cared only about the leftover? So, that was a question you also got asked in elementary school. What is the remainder when you divide 17 by 3? Well, Python has a way of giving you that. Python can tell you that 17, once it's divided by 3, will have a remainder of 2. Now, this is a special operator, and all these are operators: the addition operator, the subtraction operator, the multiplication operator, division operator, floor division operator, and finally, the modulo operator. So modulo is a way of saying, just tell me what the remainder is. It's a funky name, but hey, if you come up with the concept, you can call it whatever you want. So that's what they did. Modulo, it tells you the remainder. Now, that can get a little bit weird sometimes. Let's maybe explain modulo a little bit more. Let's say let's work with some better numbers, like 27 mod 10. So that one might be a little bit easier to think about. How many times can 10 go into 27? Well, it goes in cleanly twice. So what would the remainder be? 7. There'd be 7 left over. There you go. Now, what if we did something like negative 7 mod 10? What are we going to get out of that? That might feel super weird. You're going to get 3 out of it. So to maybe just explain what the modulo operator does, you could say it like this. The modulo operator takes your value and essentially adds 10 as many times as it needs to, or subtracts 10 as many times as it needs to, until you get a number between 0 and up to but not including 10. Now that's kind of a mouthful, but maybe another way to say that is this. Modulo 10 means you can get either 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Now, it thinks I'm typing Python code, so oops, let me change this to a markdown cell. And that, again, is something hopefully you've been doing. You've been making maybe some extra notes in your documents to kind of put headings on things or stuff like that. Modulo 10 means you can either get that as an answer. So that's what it's doing. It's saying, hey, negative 10, is it one of these values? No. Then let me add 10 since I'm below any of these values until I get one of them. Oh, I get 3 once I add 10 to negative 7. Same thing, what about 205? Well, then you would have to subtract 10, I believe, 20 times, and then you would have only the 5 that you'd get down to one of these values. Now, I chose 10 because that's easier to work with, but, you could also have mod 7, and now we're subtracting a certain number of 7s until we get something between 0 and 6, always from 0 to 1 less. So there you go. That's the way the modulo operator works. It takes a little bit of time, and you might be wondering, when would I ever use this? And we've actually got a cool project coming up where we do make use of the modulo operator, and it does definitely have a use and a need. So there's the modulo operator. So we've seen addition, subtraction, multiplication, and 3 different types of division. Do you want to know the true answer? Do you want to know the floored integer answer? And do you want to know just the remainder? You can figure out all 3 depending on what you want. Now, maybe one thing we should also discuss is that you can still use these math operators in places that might not make sense or might do things you really don't expect. So let's say you had 1, 2, 3 plus 4, 5, 6. Now these are strings, right? So what happens when you add strings? Well, you actually just put those 2 strings together and make a new string. And we call this string concatenation. And it's a really useful thing for maybe like making sentences or filling in names with variables. We'll do that later on as well. But you might be really surprised by this behavior when you encounter it, because you might think you're about to add some things, but essentially they wrote Python and said, well, this plus operator will be smart. It will work differently based on whether you have strings or whether you have numbers. It'll either do true math, or it will put these two strings together and make a new string. Now, you'll run into some errors when maybe you say, okay, I want 1, 2, 3, the string, to be added to 300. Well, then you're going to get a type error, because it's saying you can only concatenate strings with strings. So it's saying, oh, I think you wanted to do concatenation because you started off with a string and now you've got a number. Well, maybe you weren't. Maybe you were trying to do true math. So it's going to try to guess your error. Let's see what it says this time. Unsupported type for plus. You can't add an integer and a string. To me, that one makes a little bit more sense, and it's kind of a little more obvious the way it reads. Oh, I had an integer. Oh, this is a string, and it's saying I don't have the same data type on the left and right, so it doesn't know what to do. So cool. You can concatenate or put two strings together. You could even make it make a little more sense, like my favorite number is, and we got to put a space there, and we get my favorite number is 1, 2, 3 as now a new string. So it's a useful skill, but it's not math, even though it looks like math. That's why we're kind of covering it right now. You can also do something similar with lists. You could say I have a list of true, 5, and ABC. And you could also say I want to add a list that says false and 23. If I add those, I now get a new list with everything put together. So that actually kind of feels a little bit like what we're doing here with string concatenation. Take two different strings and make them one. Take two different lists and make them one, and you're actually making a new list out of this. So you can use the plus operator with lists as well. So just be cautious. That's why knowing what your data type is can save you a lot of errors, because you might be making some sort of weird mistake or doing some weird thing that you didn't realize you were doing. Oh, whoops, I had a string, not a true number, so I got some wacky errors or some unexpected behavior. Oh yeah, these are lists, so I'm not actually going to be able to add like true to false, or, let's make this make a little more sense. Let's say you had, 10, 5, and 20. And let's say you had 10, 10, and 10. And let's say, I think what I'm doing is I'm adding 10 to every single one of my values. That makes maybe some sense, doesn't it? Well, that's not what you're doing. You're actually making a new list that has 6 values, the first 3 from the first list and the last 3 from the last list. It's just going to smash them together. It's not going to combine like the first with the first and second with the second. So just be cautious of that. Now, there's definitely a way to add 10 to all these values, but we'll get there. So cool. We've seen mathematical operations, and we've seen that we need to be cautious of what data type we're using, because these have uses, maybe, and we'll see them, but they're not mathematical uses in the true sense. All right. Now, the last section is logic, and this one's a little bit more tricky, but this is dealing with these Booleans. We haven't really touched those for a little while, other than saying they exist and throwing them into a list a few times just to really drive home the concept that lists are super flexible. You can put whatever you want, a hodgepodge of different things inside of them. But what do we do with these logical Booleans? Well, one thing we can do is we can generate statements that will either run if we have a true or a false. But we also need to be able to know how we can compare like true or false, or use the or operators. So we could say true or false, and that actually just spits out true. So this is a weird, wacky concept. It's called Boolean logic. And let's just even go through kind of the 8 different things we need to be aware of. So we could say, what is true or true? Well, that's true. All right, we're going to just make 8 different lines, and maybe you might want to store these even in their own file just to say, okay, these are the 8 Boolean logic scenarios I can encounter. So it's true or true will give me true. True or false will give me false. We'll go over why in a second. False or true will give me true. And finally, false or false will give me false. So what on earth is going on here? Well, the or statement is kind of just saying, is there anything true that I can grab a hold of? It's looking for truth if it can find it. So it looks to the left side of the or, it looks to the right side of the or, and if there's a true anywhere, it's like, oh, thank goodness, I found something that's true. Let me cling to that. So if there's a true on the left or the right, or on both sides, it's going to take that true value. And if it can't find anything true on the left or the right, then it's going to give you false. So those are the 4 different scenarios you can have with or, as long as you've only got one value on the left and one value on the right. And what about and? So if something is true and something is true, well, then we get true. Now, if something is true and something is false, think about maybe like, it makes more sense here to think of like a court scenario. What if someone says something that's true and something that's false? Well, then they're not really a credible witness because they lied at one part of their testimony. So who knows what they lied about for the whole part of their testimony? I don't know. Kind of think about it like that. So same thing, false and true. That shouldn't be surprising. Is also false. And what about false and false? Well, that's definitely false. So and is kind of like looking for any break in your statement. If you say one little thing that's not true, well, suddenly I can't trust you anymore, so to speak. So or is looking for any truth it can find, and it will take it. And is looking for any little bit of false, and it's going to not believe anything else you said, so to speak. So there's and there's or. We don't need to know anything else about that, but this can get a little bit more complex. So we could also say, like, what if I have true and false or true, and I put some parentheses around this one, so this gets evaluated first. So maybe think about what this is going to spit out. It's only going to spit one answer in the end, and it is going to follow some order of operations. So what is the outcome of false or true? Think about that for a second. And then what is true and that outcome? And the final answer is true, because false or true is looking for any truth it can find, and it finds it on the right hand side. So this whole thing in parentheses becomes true. And what is true and true? Well, true, because everything you said was true, so your final statement is true. All right, so that's Boolean logic for you. Did we complicate it anymore? Yeah, we can go further. So this one's going to get a little bit longer. Actually, no, it's not. We'll chop it off here just to make it short, sweet, and concise. So we did math, we did Boolean logic, and we'll look at more comparisons in the next video. And then we're finally going to get to some looping and some logic in Python, which is going to be really exciting.